Hello everyone. Today we'll start adder program, 4-bit adder. I hope you all remember the steps. So I'll show the program first. This is the adder program, 4-bit adder module, name of the module, and these are the inputs and outputs required for adding two 4-bit numbers A and B, clock, sum, output, and this is for the state changing. So these are the input variables, output variables. Output variables are also declared as register. Here again we will make use of behavioral style of programming. So always at positive edge of clock, depending on the variable sft underscore ldbr, whenever it is 0, state must be 0. Whenever it is different, whenever it is 1, it will perform the addition. Okay, so whenever it is 0, that is else part. So there are more number of 1 statements, so we'll go for again begin and end. Within begin and end, since there are 3 different states, again we'll go for case statement. Case and state is a variable, 2-bit variable. So whenever it is 0 0, it will add 0th bit of the numbers, and state will be changed to 0 1. In the state 0 1, first bits will be added along with the carry generated while adding the 0th bit position, and the state will be changed to 1 0. In the 1 0 state, second bit numbers will be added and along with the carry generated from the previous addition, and state will be changed to 1 1. In that state, third bit position numbers will be added along with the previous carry, and it will be assigned to carry out. And this is the end of the case statement. This is the end of the begin of the else part, and this is the end of the always block, and this is the end of the module. Simple program. And next we will see the test bench program. Module, this is the name of the module, and these are the inputs variables which are declared as registers, output variables declared as wires, and this is the instantiation of Verilog code, and this is the module name of the instance. This is the name of the instance, and this is how we invoke the variables in the same order as they were declared in the Verilog code. And as usual, in the test bench program we are going to use initial, we cannot use always. So first initial block is to monitor the variables along with state variables. Okay, so we will initially assign A and B as 0, clock is 0, and this sft ldbr also as 0. Okay, then we'll keep on changing the variables after certain instance of time in the next initial block, with every 10 for every alternate 10 nanoseconds clock also will be inverted. We'll see that in the next initial block. Here A is initialized to 1011, B is initialized to 1110, and this sft ldbr is initialized to 0. So here with this as 0, it will start with 0th bit addition and so on. So after 30 nanoseconds, we'll change this variable to 1. After 130 nanoseconds, again to 0, and again back to 1. So this is the end of this initial block and end of the module. So in one initial block, we are monitoring the changes in the inputs. In the other initial block, we have initialized A and B to some values. Okay, this is the test bench program of adder. Okay, now we will come back to digital, and in the space here, empty space here, click and open terminal. First we have to invoke the cadence tool. So csh source cssrc underscore test. So tool is invoked. Since program is already ready, we will directly launch simulator, and the programs were here in the programs underscore Verilog, add and add underscore tb. So we will compile both one after the other, add underscore tb. If there are any errors, it will be displayed here, otherwise it will be no errors. Then after compiling, click on work library here, and one by one we have to elaborate. No errors after elaboration. Again no errors after elaboration. Then we have to go for snapshots and consider test bench program library created for, and select the library created for test bench program and launch simulator. Yeah, this is what we get after launching simulator. We can minimize SimVision. Click on this. So here are the inputs and outputs variables. Right click, send to waveform window. Okay, so again everything is being initialized in the test bench itself. So we can simply click on the time window. Okay, I did not give the time variable, so I'll close this now and I'll launch it again. Send to waveform window. I think I have to close everything. So test bench module, launch simulator. Okay, minimize SimVision. Right click, send to waveform window. First give the time, so it was around 200, so I'll give around 400 and then click on run. Okay, this is the result of the simulation. Okay, here initially the value of A is B, uh, B in hexadecimal, and the value of B is E. Clock is high, so whenever this is 1, SFT LDBR is 1, sum is 9. Actually B plus E is 19, that is C out, that is in the C out is high, so C out and sum we have assigned. Okay, so 1 and sum is displayed as 9. This is the output of 4-bit adder. Thank you.